Unit 10, day S, or 5 if you're counting like normal people. This is more inverse trig functions. Well, I should say more practice. There's not any more trig functions to learn, so we know the ones that we've seen the ones that we're supposed to know. Let's quickly review. Some of them come from quadrant 1 and 2, and some of them come from 1 and 4. Inverses. So which trig functions have inverses that we pull from quadrant 1 and 2? Cosine's the main one. After that, you can kind of figure out the others. Who's usually partnered up with cosine? Secant. And then cotangent's the one that's maybe a little bit weird because he is not partnered with tangent. And the reason is the asymptotes. Negative pi over 2 to pi over 2 is inverse sine, inverse cosecant, and inverse tangent. And again, if it's in the fourth quadrant, we go there the quick way, not the long way around. Stay out of the quadrant of death. If I could draw a skull and crossbones down there, I would do it. Instead, it just gets a big red X. Stay away. Caution, keep out. Don't go to it, don't go through it. All right, 2 Roman numerals today. You kind of already know everything you need to know, so there's not like any new concepts. It's just practicing things that we already know. The first set are unit circle problems. The second set are picture problems. We'll worry about those in a moment. Unit circle problems. Sine of the arc cosine of 1/2. So it's unit circle problems. It's just 2 problems sort of nested in one. It doubles your chances of making a mistake, right? That's the pessimistic way to look at it. Doubles your opportunities to show what you know. It's a better way to say it. So, as always with math, when there's parentheses, work from the inside out. So, ignore the sign for now. Just arc cosine of 1/2. Some people do these all in their head. I usually end up drawing a little bit of a picture. Cosine's got to come from 1 and 2. It's positive, so it's coming from 1. We answered this question already, I think, today. What angle has a cosine of 1/2? I mean, I'm pretty sure it's either over 3 or over 6. And if I want the x length to be 1/2, that would be pi over 3. And then the second part of the problem is, what's the sine of pi over 3? Root 3 over 2. So it's like, you already know how to do these problems. It's just double testing your unit circle knowledge. Cosine of the arctan of negative root 3 over 3. Cosine of the arctan of negative root 3 over 3. Cosine of the arctan of negative. That's just a lot to think about. Kristen, what quadrant is my answer going to come from? I mean, not the full answer, just that part of the answer. Where is the arctangent negative? 4. Good. I guess 2 and 4 the way I asked the question, but we know we have to pull from 4. So I got to get something from 4. Our tangent 3 trick means, what's the denominator going to be? If the arctan is root 3 over 3, that denominator is going to be 6. And Kristen said fourth quadrant, so fourth quadrant, because it's negative, over 6, because 2 3s make a 6. So what's the over 6 angle in the fourth quadrant? Good, negative pi over 6. What was I worried someone was going to say? 11 pi over 6. It's like, well, yes, it's there, but that's not you're not allowed to go that way. You have to go the quick way. So negative pi over 6. And then the cosine of negative pi over 6. These are kind of nice because once you draw the picture for the first part of the problem, you usually have the picture drawn for the second part of the problem. Not always, but usually. So the cosine of negative pi over 6, got the picture already there, is root 3 over 2. Number 3, the inverse cosine of the cosine of 4 pi over 3. The inverse cosine of the cosine of 4 pi over 3. Well, start on the inside. That's the cosine of 4 pi over 3. Maybe a quick sketch is necessary.
It's steep in the third.
It's steep in the third. That's a great answer. And I want the x-coordinate of steep in the third. Negative 1/2. Good. Then I want the inverse cosine of negative 1/2. Uh-oh, that picture doesn't qualify anymore. Because if I want inverse cosine, it's got to come from 1 and 2.
No.
The answer is going to be positive, yes. So I need the over 3 angle in the second quadrant. So that'd be 2 pi over 3. It's just stacked unit circle problems. I've warned and warned and warned. If you don't know the unit circle, you've got to learn it. And learn it well. One more of these, then we'll move on to the picture problems. Arctangent of the sine of 3 pi over 2. Why don't you try that one? Yeah. So inside out, sine 3 pi over 2 is negative 1. Arctangent of that is negative pi over 4. Roman numeral 2. For this, you don't need to know the unit circle. So this may be great news for some of you. The audible celebrations. Okay. The sine of the inverse cosine of negative 4/5. Let's see. Cosine. Cosine. Where's the cosine negative? Right, second and third, but I'm not really allowed to use the third. So second quadrant. So basically we draw the picture based on the inside information. What's cosine in terms of X or Y or R or H or all those letters? I heard X and adjacent, and both of those are fine. So it's either X over radius or it's adjacent over hypotenuse. Either way. Or if you want to combine them, that's fine too. The hypotenuse then is 5. The X is negative 4, which makes sense because we're in the second quadrant where x would be negative. For the outside, we'll use the picture. So the inside stuff, draw the picture. For the outside stuff, use the picture. What's sine in terms of?
It's probably be
So opposite over hypotenuse, or y over r.
Yeah.
What is y equal to there?
It's gonna be the
I mean, it's this side. What's the length of that side? How'd you know it's 3?
because it's 3, 4, 5.
It's a 3, 4, 5 triangle. We use a lot of those
U1.
special right triangles today to make life a little easier. So then my answer is 3/5. There were no unit circle values involved in the production of that problem. Now, we still needed to use SOHCAHTOA and know some stuff about quadrants, but I didn't need to know any unit circle values. A little side note here, you all knew 3, 4, 5. Do you know any of the other special right triangles? 5, 12, 13. Yep. 8, 15, 17. There are others, but usually we don't go beyond that. And if you don't remember beyond that, you can just use a squared plus b squared equals c squared. But these make life a little easier, just like I think all of you knew that was a 3, 4, 5 triangle. If you know the others, it just makes the worksheet go faster rather than you trying to find the missing side. All right, the tangent of the inverse sine of 8/17. Tangent of the inverse sine of 8/17. Y over r. What quadrant am I drawing this in?
That's probably the. It's either first or.
Why the first? It's positive. Anything positive is going to be in the first. So I know I'm going first quadrant. I guess if I planned ahead, I could draw my triangle to scale, but it doesn't really matter. It's more about putting in the right quadrant and putting it in the right pieces in the right spot. Let's see. Opposite or y is 8. Hypotenuse or radius is 17. So my missing side is 15. And then tangent is, again, draw the picture based on the inside stuff. And then use the picture. Tangent is opposite over adjacent. Or y over x. Opposite over adjacent, y over x, 8/15. This little section is preferred by people who understand quadrants and know about SOHCAHTOA, but still struggle with unit circle values because they're not needed here. All right, let's try to really mess one up here. The secant of the inverse cotangent of negative 5/12. Well, that's about as awful as it can be. First of all, what quadrant am I going to draw that in?
So it's gonna be there.
Well, think back. Cotangent. Cotangent is first and fourth with cosine and secant. Excuse me, first and second. Drew the right thing. So I got to draw it in the second quadrant. What is cotangent in terms of x and y? Yeah, x over y, or adjacent over opposite. Heard somebody say that, and that's fine, as long as you remember which one goes where. So the x is 5, the y is 12. Why is that?
13.
Well, that's the next question I was going to ask. Where'd that negative come from? Who's negative, the 5 or the 12? The 5, because it's backwards. And then, yes, the hypotenuse is 13, because 5, 12, 13. Cosine, excuse me, oops, that was the answer to the question I was going to ask.
Cosine.
Wow, you read my mind. We don't do secant really, we do cosine. We need a flip of cosine. Cosine is cosine is x over r. So secant would be r over x. And then we just look at our picture. Negative 13/5 r over x. You can put the negative in the bottom, but most people prefer the negative in the top. So either way. Draw the picture in the correct quadrant and then use the picture. Last one. Tangent of the inverse sine of 4/3. Actually, why don't you try that one? It's the last one, so you give that one a try. So use the inside to draw the picture, then use the picture to answer the question. So y over r, 4 over 3. It's not a 3, 4, 5 triangle, because that only works if the 5 is the hypotenuse. A squared plus 4 squared equals 3 squared. So a squared equals 9 minus 16, which is negative 7. What is going on here?
It's weights.
In any right triangle, what's the longest side?
That's whack.
So that's whack is the correct answer. I can't have the hypotenuse be shorter than one of the sides. So that does not make a triangle.
No solution.
No solution. That's not possible. And I didn't even tell you that was a possibility before I asked you to try it, so you can blame me for that. All right, today's assignment's worksheet 5. Let me not warn you, that's not the right word. Caution you, alert you. So that's Monday's assignment. Tuesday's assignment is review. Wednesday's assignment is review. Thursday is test. There's only one worksheet or one review worksheet in there. So you can decide how you want to do worksheet 6. Right? If you want to do odds one day and evens the next, that would seem like a wise thing to do. If you want to do all of worksheet 5 and 6 tonight and then not do anything,
Do the whole packet.
that's fine. That's probably not advisable. You should probably save some of it for Wednesday night to study,
I still
but
have to do the whole packet.
whatever. So I'm just kind of calling your attention to it. There's one worksheet over the next 2 days. That's a good problem to have. But plan your time accordingly so that we land on you get it all done by Thursday.